Hello and welcome to this video in which we will further read more library functions of string type. So if you are new to the channel, then make sure you subscribe to the channel and press the bell icon so that you can get notifications about upcoming videos on this channel about Python programming. So we were going through this library reference of Python, and we were going through str type, that is the string class, and we had studied till lstrip, and now we will move further on mectrons. So without further ado, let's get started. The next function is static str mectrons. This static method returns a translation table usable for str.translate. If there is only one argument, it must be a dictionary mapping Unicode ordinals to or characters, strings of length 1 to Unicode ordinals, strings of arbitrary lengths or none. Character keys will then be converted to ordinals. If there are two arguments, they must be strings of equal length, and in the resulting dictionary, each character in X will be mapped to the dictionary to the character at the same position in Y. If there is a third argument, it must be a string whose characters will be mapped to none in the result. So for example, I have taken a dictionary where I map pound to yen, and I get the translation table by calling make trans, and then I invoke on pound the translate method. So you can see the result here. If I run this, the pound is mapped to yen. So that's how we are supposed to make use of this. Of course, you can make other examples of strings of equal lengths. For example, two argument one, I can show that hello to Dello, okay, and not like this. I mean, if you want two strings, you can make here hello to Dello. Equal length is required, and then we say my name hello Shiv, and then we say again hello Shiv. Okay, then you will see it will print Dello Shiv. So you can have a string pair of strings rather than a dictionary. str partitions takes an argument called separator, and it splits the string at the first occurrence of separator and returns a three tuple containing the part before the separator itself, and the part after the separator. If the separator is not found, return a three tuple containing the string itself followed by two empty strings. So for example, you can say uh, my name is Shiv, and you can invoke partition, and we will take separator as say is. Okay, so it should return us three tuple output. So it gives us three tuple my name space is space Shiv. So that's how the partition function works. str.remove prefix. If the string starts with the prefix string, then string len prefix colon, otherwise return a copy of the original string. So you see the example test hook, the remove prefix takes the argument test, and it removes test from the string, and hook is returned. In this second case, test is there in the string, but it is not at prefix position, so the copy of the string is returned. Remove suffix, and it takes argument suffix, and it ends. If the string ends with suffix string and the suffix is not empty, then return string colon minus len suffix. Otherwise, return a copy of the original string. So in this case, tests is the suffix which is removed, and miscellaneous is returned. And in this case, test is not there, so original copy is returned. str.replace. Return a copy of the string with all occurrences of substring old replaced by new. If the optional argument count is given, only first count occurrences are replaced. So for example, in this case, I can say dot replace, I can say Shankar, which is my second name, middle name. So, oops. Oh, okay, it did not find it. It takes two arguments, right? Shiv and Shankar. So yeah, it replaces that way. And if you want count, then you can replace the count 2 also. But there is only one, so it will replace once. rfind. It is the reverse find. Return the highest index in the string where substring sub is found such that sub is contained within s start colon end. Optional arguments start and end are interpreted as in slash notation. Return -1 on failure. This is similar to find which we have studied. R index like rfind, but there is value error when the substring sub is not found. R justification. This is same as left justification. You supply width and fill there. We have already studied this. R partition is same as partition, but from the other end. R split is same as split, but from the other end. R strip is same as stripped, but from the right hand side. And split is given here. So R split we have not seen the detail. So we will look at split. Return a list of words in the string using separator as the delimiter string. If max split is given, at most max splits are done. Thus the list will have at most max split plus 1 elements. If max split is not specified or -1, then there is no limit on number of splits. If separator is given, conjugative elements are not grouped together and are deemed to delimit empty strings. For example, 1 comma 2 dot split comma returns 1 empty string 2. The separator argument may consist of multiple characters. For example, 1 less than greater than 2 less than greater than 3 dot split less than greater than returns 1 2 3. Splitting an empty string with a specified separator returns empty string. So for example, here 1 2 3 is split with comma, so you get 1 2 3. You split with comma with max split 1, then 1 and 2 comma 3, 1 comma 2 comma 3 comma split by comma, then you get 1 2 empty string 3 empty string. If separator is not specified or is none, a different splitting algorithm is applied. Runs of conjugative white spaces are regarded as a single separator and the result will contain no empty strings at the start or end if the string has leading or trailing white spaces. Consequently, splitting an empty string or a string consisting of just white space with a non-separator returns empty string. For example, 1 space 2 space 3 dot split will split on white spaces, so you will get 1 2 3. And if max split is 1, then it will be split 1. And if there are empty spaces before and end, then they won't produce new strings, so you will get 1 2 3 in the final case here. Split lines. Return a list of lines in the string breaking at line boundaries. Line breaks are not included in the resulting list unless keepends is given and true. This method splits on the following line boundaries. In particular, the boundaries are a superset of universal new lines. The new lines are \n, \r, rn. This is Windows style line breaks. Vertical tab /v, form feed /f, file separator \x1c, group separator \x1d, record separator \x1e, \x85, next line, line separator u2028, and lines paragraph separator u2029. So this is mostly used when you do file IO. You read the entire file in the buffer and you can invoke split lines or read lines, which internally will make use of this. So for example, ABC, AB space C \n, DE space FG \r, KL \r When you split, you will get AB space C followed by empty string, then DE space FG followed by KL. If it is AB space C \n, DE space FG \r, KL \r \n, and you say keepends is equal to true, then the last \n is kept here, and \r is also kept here, and \n is also kept here. So if you give keyprints to, then white spaces are not removed. Unlike split, when a delimiter string separator is given, this method returns an empty list for the empty string, and terminal line break does not result in an extra line. For example, empty dot split lines will give you empty string, and one line \n split lines will give you one line. In comparison, \n split \n gives empty split \n will give you an empty string. Two lines \n split with \n will give you two lines and then empty string. str.start with this function returns true if string starts with the prefix, otherwise return false. Prefix can also be a tuple of prefixes to look for. With optional start, test string beginning at that position. With optional end, stop comparing string at that position. So this can be shown like this. Starts with, and we can give a tuple. Yeah, we can give a tuple like my comma name, and we'll see it will return true. str.strip, it's a combination of rstrip and lstrip together, so all the white spaces at the end will be removed. So you can see that it is only spacious, and if you give some argument characters, then those will be removed from prefix and suffix both positions. So www dot and .com are removed. The outermost leading and trailing chars argument values are stripped from the string. Characters are removed from the leading and end until the string character is not contained in the set of characters in the chars. Similar action takes place on the trailing end. So that's there is not much in this. str.swapcase returns a copy of string with uppercase characters converted to lowercase and vice versa. Note that it is not necessarily true that s.swapcase is equal to s. Because in some cases, as we studied, the German beta was translated to SS, but the reverse may not be true. str.title return a title case version of the string whose words start with an uppercase character and the remaining characters are lowercase. So hello world is .title will give you hello and world with capital W. The algorithm uses a simple language independent definition of a word as a group of consecutive letters. The definition works in many contexts, but it means that apostrophes in contractions and possessives form word boundaries, which may not be the desired result. For example, if you have a apostrophe here, they are, then the R will be capitalized. Bills, S will be capitalized. So it can become a problematic thing. So the alternative workaround for apostrophe is done using regular expressions. I cannot explain this because we have not covered regular expression yet. Once we cover regular expression, I will try to come back here and explain if I remember it at that time. So please, if str.title, okay. I'll make sure that I come back to this. str.translate return. This we have already seen in combination with make trans. So I'll just read it. Return a copy of the string in which each character has been mapped through a given translation table. The table must be an object that implements indexing via getItem, typically a mapping or a sequence. When indexed by a Unicode ordinal, the table can do any of the following: return a Unicode ordinal or a string to map the character to one or more other characters, return none to delete the character from the return string, or raise a lookup error exception to map the character to itself. You can use str.maketrans to create a translation map from character to character mapping in different formats. See also the codex module for more flexible approach to custom character mapping. str.upper is similar to lower. str.lower, it will convert a string from lowercase to uppercase characters to uppercase. Note that s.upper.isUpper might be false if s contains uncased characters, or else the Unicode category of the resulting characters is not LU, but LT. The uppercasing algorithm is described here. So this we have already seen. str.getFillWidth return a copy of the string left filled with ASCII 0 digits to make the string of length width. The leading sign plus or minus is handled by inserting the padding after the sign character rather than before. The original string is returned if width is less than equal to length. So 42 Z-fill5 will give us 3 zeros filled before it and then 42. Minus 42 Z-fill5 will give us minus followed by 2 zeros and then 42. So with this we are done with the string, and next topic is printf style formatting, which is a big topic in itself. There's quite a lot of things to go through, so I'll stop here, and in the next video we will go through printf style formatting, and I hope that you're enjoying this read through of Python library reference. And make sure to like the video, share it on social media, or engage with me in comment box. We can talk about various stuff and we can plan or discuss new things. So let me know what you think in the comment box. Please make use of it. Thanks a lot for watching. Happy programming.